You know linear Rust programming, but then you think this isn't enough and start learning threads. Many have problems with them, so today I'm going to talk about them. If you like what I'm doing, even small life savings are appreciated. Well, let's say we need two loops working independently. How can we do it? We need to create two threads and start a loop in each. To create a thread, first import std_thread and then spawn it. This means it's a code block. Put a loop in each and that's it. Well, the code we've just made isn't really safe because nothing guarantees the threads and therefore the loops inside them will have finished before the end of the main function. To fix it, we need to store each thread in a variable and join it at the end. This will block the code from finishing before the end of each thread. To use any kind of variable inside a thread, we need the thread to take full ownership of the variable. If you have no idea what I mean by that, I recommend you to watch this video. But for now, just take it as a fact. Now let's say the idea of the code is to go through a hash set and find the greatest number inside it, and do it all using threads. Well, for that we can use arg along with rwlog. The latter type allows you to read as many times as you need and write only once at any point in time. I kind of recommend you this exact combination. Let's keep the current greatest number in a variable and wrap it into both arg and rwlog. For each number in the hash set, we need to create a new thread and throw the handle of the thread into a vector of handles. Then we compare the current number with A. Now that's called locking. Again, if you use rwlog, you can log for writing only one time and log for reading as many times as you want. Now let's look at an example where using threads makes the program significantly more efficient. Let's say we have this code doing completely arbitrary stuff. We just need that stuff to be rough enough for the CPU. We have a vector of floats. Then we I times assign the jth element of floats to this nonsense. We also measure how many nanoseconds the execution takes. That is pretty long. Now let's say we have a hypothesis that if we run each j in a separate loop, we'll get better speeds. Well, here's the equivalent of the linear method, but with threads for each j. As you can see, I clone floats for each j. Then inside the thread, I lock it as write. Please remember this pattern if you need to share data between threads. It's faster now. What's also funny is that if we make one of the loops shorter by lowering this constant, the linear method will be faster, and that's probably because it takes more time to organize the threads. So there is a line between threads giving or stealing performance. That's just a funny thing I've noticed. Also, if you don't believe Rust actually separates these tasks between CPU cores, you can call C from Rust, gigachat, and get the current core of the thread. Threads in Rust have a deep learning curve, but they can often help you in many ways, so use them and tell me what you'd like to see next.